Thank you all for attending today. Thanks for the intro, and I'm here to tell you about the McIntosh Graphite deposit, which is Western Australia's largest. Lots of important information in there. This is on the website. You can go through it in your own time. Investment highlights. So what makes McIntosh good? Basically, we're here in Australia. Low sovereign risk. A lot of this supply coming, all the new supplies coming from Africa. We like to think we can do things better here, and it's a much safer place to operate. Flake size. We have a good mix of coarse and fine flake. That's good for product diversity. It means we don't need to sell into one market, and I'll touch on that later. High purity. This is also really key. If your flake graphite doesn't purify to a certain level, then it's not a saleable product. And I'll take you through exactly what we've done, the test work so far, but we've achieved 999, which is basically exceeding the requirements for the battery industry. And the high purity is a higher value product. This is a nationally strategic mineral in Australia, in the UK, in Europe, and we're tapping into the funds and incentives. Okay, I just want to draw your attention to the market cap on this slide. We're just under 12 million, 4.4 in the bank, leading to a 7.5 enterprise. That makes us one of the cheapest or undervalued stocks on the ASX. So lots of room for upside here. We're just getting our story out there again, and we are expecting a re-rating from that. Experienced team. We've got our executive chairman, Dr. Liam Pretorius. He's got over 30 years of experience in uranium and other metals, and that's rounded out with Charles and Chris in the corporate and legal sections there. We've managed to snag some of the best graphite advisors, sort of the A-team in both metallurgy and in sales and marketing, so we're really pleased to have both Oliver and Chris on board. We've been, you've probably heard this a lot today. If you've been living under a rock, everybody understands that there's a huge demand in EVs, and that's what's driving the demand in graphite. I guess one of the major issues is that most of this graphite is coming from China at the moment. We need to break that supply chain. So basically to feed the demand for the graphite for these gigafactories that are turning up in the US, in Europe, we need a significant amount of graphite to feed those plants, but also it needs to be outside of China, because as you've just heard earlier, there's going to be, I guess, legislation imposing that it needs to be sourced from either within the EU or one of the EU's associated or countries. This really, for every EV, everyone thinks about lithium, nickel, and copper, but in reality, every EV, the largest amount of material that goes into it is graphite. And so for every EV, on average, we need 66.3 kilograms. And that's because half of the battery is the anode. This is another really important point. A lot of the supply of graphite is synthetic, and it's basically a waste product from the oil industry. It's needle coke, and you need to put it under 3,000 degrees for 3 weeks to turn it into synthetic graphite. That takes a lot of energy, and therefore the CO2 footprint is significant. Whereas here with the McIntosh graphite and any natural flake graphite deposit, Mother Nature has already done that, and so there's a significant difference in the CO2 footprint for this natural flake graphite, and that's also important. Once again, the EU is legislating that carbon footprint is put on the battery, And the anode at this stage is one of the worst polluters or offenders because most of it's coming from this synthetic graphite. Project location. So tier 1 location here in WA. We are only 12 kilometres away from the Great Northern Highway. I couldn't ask for anything better. So it's going to be a low capex to establish this project. It's in a very good location. 280 kilometres to Wyndham. Our peers, Panoramic Resources, they're exporting from there. It's a deep water facility, and it's more than enough for us to export our graphite concentrate from there. The other key point is the Lake Argyle hydroelectric facility. This is really important to us because we want to achieve net zero or close to low carbon graphite production. And if we can get our power demand from hydroelectric, that's going to go a long way to meet those goals. McIntosh Project. So GCM has the right to earn 80% of that through a staged earning. We've already met the first hurdle. It is West Australia's largest graphite resource, 23 million tonnes at 4.5 total graphite content. Compared to our peers, some may say that is lower grade, but that's, if you understand the graphite industry, it's all about the flake size distribution and the purity. These are the two keys here. So grade takes a backseat in this case. It's actually one of the most advanced graphite projects in Australia. It already has a PFS on it back in 2017. It's just unfortunate the graphite market wasn't there back then. So it's already had a significant amount of money, up to 14 million spent on this. So we're looking to update that pre-feasibility study with new prices for graphite, because the prices are steadily going up, and introduce new technologies and new ways to make this PFS better. So the Emperor deposit is, I guess, the major deposit within the McIntosh resource. It is 67% of the resource, and the folded nature here. Sorry, the folded nature here allows a low stripping ratio. So there's a significant benefit here. Just touching on flake size, the Emperor deposit is a large flake deposit. The larger the flake, you get a premium. So we're up closer to this value down here. But we also have a finer flake deposit as well in our other deposits. So we're going to have a diverse stream. So this coarse flake will go to the expandable market, where there's a sort of the flame retardant industry. It goes into building materials, and the finer flake will go into the battery anode. So a diversified product mix there. Purity. This is one of the keys I was touching on earlier. If you can't purify your graphite to 99.95, then forget it. And there will certainly be graphite deposits that will struggle to get up to this purity level. Not only did we get to 99.95 on previous test work, we exceeded that, say 999. So this is what we call nuclear grade. This is an extremely high value product. It's pure enough to be used in nuclear reactors, and that's a $30,000 per ton product. The other benefit of the McIntosh flake is that it's easily purified. Because the purification step is energy intensive, if the impurities are situated on the outside of the flake, which is the case of McIntosh, it means that those impurities can be easily washed off. If they're located sort of inside the flakes or intercalated, that's going to require much more advanced processing and much more, that will increase the cost of your purification step there. So because McIntosh flake is easily purified, it's going to make us in one of the lowest quartile producers of this, and also because it's going to be a high product margin, we're going to get, because it's a high value product, we're going to get a high margin from it. So we've already done the battery anode test work. It's passed on all criteria. Basically, this is the reference material for SPG, or the precursor to battery anode, and so this is the yield. Basically, it's when you're creating battery anode, not all of the material makes it through to product, and typically there's 55% yield in the industry, but we're at 58% at the moment. We're looking at ways to increase that. We believe we can get up to 70% there. Everything else was passed there. Critically, so I talked about 99.95 earlier. So the question is, what's in that other 0.05? And McIntosh shows that basically it doesn't have any of these nasties in that remaining, and that's critical because it's not all about just getting 99.95. If you have these remaining nasties, these critical elements here, if they exceed these certain levels, then it's not going to be good for battery anode material. The other key thing here is that this purification method was thermal, so we're not using hydrofluoric acid. The hydrofluoric acid is used in China at the moment, and it is devastating to the environment. So we can achieve this using hydrofluoric acid-free technology, which is basically a thermal furnace. And if we can power that furnace through that hydroelectric power, then that will lead to a low carbon, low to zero carbon product. There's upside at McIntosh. So our current resource is in these yellow little blobs here. So that's where the 23 million tons is. Graphite is quite easy to find because it either outcrops at the surface or is very easily picked up in geophysics. So you can see these lines through here. These are all strike extensions of the graphite. So we've got plans to go in and drill these extensions. And essentially, we've got a target of 67 to 101 million tons, and that will more than double our current resource. So our business strategy, as I mentioned earlier, we've already got a PFS on this completed back in 2017. That PFS concentrated on one flake size, and it destroyed value by grinding down these coarse flakes. So we're looking to preserve the coarse flakes because they get the higher, it's a higher premium market. The other thing we're looking at is ore sorting technology. And in fact, the whole industry should be looking at ore sorting technology. As grades become lower and lower, we need to get used to mining lower grade material. And so a lot of what we put through the mill is actually waste rock. And the milling is the most power intensive part of a mining operation. So if we can reduce the amount of waste going into the mill, you can significantly reduce your costs, your operating costs, but more importantly, instead of building, say, a 1 million ton per annum plant, you only need to build say if you're rejecting 40% as waste, you'd only need to build a 600,000 ton per annum plant. So that's significant there. And ESG benefits as well. If you're putting less waste into the mill, you're using less energy, and also you're not sending waste material to a wet tailings dam, which is an environmental risk. So we aspire to be a vertically integrated graphite producer, so trying to keep this in WA, and so the raw graphite concentrate is a valuable product. Typically, if we take our average basket of goods, it could be in the order of $1,500 to $2,000 for just the raw graphite concentrate, but we're not here for that. We'd like to get into the higher margin downstream processing. Typically, that bumps things up into the 3,000 to 4,000 mark if we're going into the batteries. But if we're going into the coarse flake market for expandables, which gets rolled out into graphite foil, that's more the $15,000 to $18,000 per ton. So we're gonna focus on both that multi-product strategy, so both coarse flake and the fine flake. We're gonna review locations for where that downstream facility could be, and we're going to start the qualification process for the battery anode. We really want to start focusing on offtake agreements now. There's enough prior work for us to go to off-takers to start talking about our product. Yeah, like I said here, because we've got both coarse flake and fine flake, the fine flake into the battery anode does take a significant qualification period. It takes about 2 to 3 years to qualify your graphite to be for a battery anode, because they're very specific about the requirements. So during that qualification period, we're exploring a business model where we sell our coarse flake to prop up and help us through the qualification period. And that's it from me. That's just the main takeaways. Thanks very much for your time.